Welcome back to the deep dive. This is where we take a whole stack of information, break it down, and give you those key nuggets, really a shortcut to getting properly informed. Today, we're diving into a system that, well, it quietly runs a lot of the physical world around us. Think about the products you buy, even some services you use. Our mission today, it's to unpack materials requirement planning, MRP. It's foundational, really, but it's evolved into these incredibly complex systems driving modern business. We're using a great source today, OpEx-SCM Funda4 MRP.pdf. It's a guide focused on operational excellence. So if you've ever wondered, how does a company know exactly how many screws or how much metal or even say how many rolls of bread they need and when they need them, then yeah, this deep dive is definitely for you.
It is fascinating, isn't it? Because it seems simple on the surface, but MRP tackles this fundamental challenge. Knowing what you need and, crucially, when you need it. Especially when demand isn't just straightforward. This dive will really show you how businesses get their arms around that complexity.
Okay, so let's kick things off with a really core distinction. It sets the stage for everything else. Dependent versus independent demand. Sounds technical? Maybe. But it's actually pretty intuitive.
Yeah, it is. So independent demand, that refers to items where the demand isn't directly tied to making another item. Think finished goods, stuff customers buy directly. Their demand, while you usually estimate that using forecasts, maybe actual customer orders already booked, planning methods often involve things like EOQ, economic order quantity, or ROP, the reorder point.
Right, so if you're, let's say, making bicycles, the demand for the finished bicycle itself, that's independent. You're forecasting how many people might actually want to buy a bike.
Exactly. Now, dependent demand, this is where it gets really interesting and where MRP comes in. This is for items whose demand is directly derived from it, depends on the production of a parent item. So we're talking raw materials, components, maybe work in process or WIP items. Their demand isn't forecasted, it's calculated based on the demand for the finished product. And MRP is the main way you plan for these.
Got it. So the wheels for the bicycle, the handlebars, the frame itself. The need for those parts depends entirely on how many finished bicycles you actually plan to build.
Precisely. And, for these dependent demand models to work well, the operations manager needs specific info. You need the master production schedule. We'll get to that. You need the specifications, the bills of material. Again, more on that soon. You need accurate inventory status, what purchase orders are already out there, and critically, the lead times for everything. It really highlights how interconnected it all is.
Okay, so with that demand distinction clear, let's talk about those two critical components you just mentioned for managing dependent demand.
Yeah.
Master production schedule, the MPS, and the bill of material, the BLM.
Right. So you might have an aggregate production plan, which gives a high-level view. Like maybe a company needs to make, say, 1,200 to 1,500 amplifiers total in a given month. The MPS then takes that and breaks it down. It gets specific. It'll say, okay, we need this many 75 watt amps, this many 150 watt amps, this many 240 watt amps scheduled for these specific weeks.
Ah, okay. So it's going from that, like, broad brushstroke to a really detailed painting of exactly what needs to be produced and when. The source also mentions the MPS can focus differently depending on the business.
Yes, that's an important point. What's the typical focus? Well, it depends. For stock-to-forecast environments, think steel. Maybe beer, you schedule the finished products. But for assemble-to-order or forecast, like motorcycles or TVs where there are options, you might schedule key modules. And then for make-to-order places, like a custom print shop or maybe even a fine dining restaurant, you're scheduling the key inputs. So paper, ink, or maybe specific ingredients. That adaptability is really key.
Okay, so once you know what final product you're making, you absolutely need the recipe, right? And that's where the bill of material, the BOM, comes in.
Indeed. The bill of material, or BOM, it's essentially just a list. A list of all the components, the raw materials, the subassemblies, and the quantities of each needed to make one unit of a product. It gives you the product structure. Sometimes people visualize it like a tree. You have parents, the item being made, and children, the components going into it. It also uses something called low-level coding. The top item, the final product, is level 0, then the components are level 1, their components are level 2, and so on, down to the lowest level where an item appears anywhere in any structure. It helps the system process things in the right order.
Right. The source has a good visual for a product called Awesome A, showing all its bits and pieces. And the bicycle example is clear, too. One bike needs one handlebar, one frame assembly, 2 wheels. Simple enough there.
Yeah, and what's also interesting is that there are special kinds of BOMs for specific situations. You have modular bills, which group components for options, making planning easier for configurable products. Planning bills use an artificial parent item just to simplify forecasting and master scheduling. And then there are phantom bills. These are for subassemblies that exist only temporarily during manufacturing. They aren't really stocked items. They just pass through.
Interesting. So different BOMs for different planning needs. And then if you add lead times, how long it takes to get or make each part, you get what's called a time phase product structure. That sounds like the real roadmap.
It really is. It tells you not just what you need, but when you need to have it ready or when you need to start making it to meet the schedule for the next level up. It maps it all out against time.
Okay, so we have demand types. We have the MPS telling us what and when, and the BDM telling us how. How does MRP actually, pull this all together?
So at its core, MRP is a manufacturing computer information system. Its main job is figuring out the quantity and the timing for all those dependent demand items, the components, the materials needed for production. It's really crucial for discrete products items you can count, like individual bikes or amplifiers.
And what does a company absolutely need to have in place for MRP to actually work effectively? What are the must-haves?
Okay, for MRP to be truly effective, a few things are non-negotiable. First, you need an accurate bill of material, really accurate. Second, you need a highly accurate inventory status. The source actually emphasizes 99% inventory accuracy. Think about that, knowing exactly what you have on hand 99% of the time.
Wow, 99%.
Yeah, it's a high bar. And third, you need stable lead times. If your supplier delivery times are all over the place, it makes planning incredibly difficult. Without these, the MRP system's output, well, it just won't be reliable.
That 99% accuracy really stands out. But it makes sense, doesn't it? Garbage in, garbage out.
Yep.
So assuming a company can achieve that discipline, what are the big wins? What are the benefits of implementing MRP well?
Oh, the benefits are significant. Huge, really. Companies see increased customer satisfaction big time because they can actually meet delivery schedules more reliably. They achieve faster response to market changes. They become more agile. You see improved labor and equipment utilization because things run smoother, better inventory planning and scheduling overall. And, the bottom line often is reduced inventory levels without hurting customer service. That frees up cash, reduces waste. It raises a really good question. Just how much efficiency can you actually gain by cutting waste and perfecting that timing?
The source kind of shows us the structure, doesn't it? The MRP system puts the MPS, the BOM lane, lead times, inventory data, purchasing data, feeds them into the MRP planning programs,
Right.
and then generates these vital outputs.
Exactly. The outputs are things like MRP reports showing needs by period or date, planned order reports telling you what orders to release, whether for manufacturing or purchasing, purchase advice for buyers, and, really importantly, exception reports. These flag potential problems. Maybe an order is late, maybe you'll run short of something. They highlight where managers need to focus. And if you connect this to the bigger picture, you see MRP as part of this larger production planning cycle. You've got aggregate planning up top, then MPS, then MRP, capacity planning checks, shop floor schedules, and crucially, there are feedback loops all the way. Checking if the plan is feasible, making adjustments. It's a dynamic process.
It sounds like a very logical machine. But are there any quirks, any specific dynamics in how MRP operates that people should be aware of?
Yeah, there are a couple of interesting dynamics. MRP does support replanning, which gives it flexibility. You can update plans based on new information. But if you make changes too often, it can lead to something called system nervousness. Just constant minor adjustments rippling through the plan, making it unstable and hard for people to follow.
System nervousness. I can picture that. Constant little changes causing chaos. How do companies deal with that?
One common technique is using a time fence. Basically, you designate a period in the near-term master schedule as frozen or firm. Within that fence, the system won't automatically reschedule things. It creates a zone of stability.
That makes sense. Build in some stability, especially for the immediate future. Okay, what about understanding why you need a certain component? If there's a potential shortage, how do you know what it impacts?
That's where a feature called pegging comes in. Pegging lets you trace upward in the BOM. So if you have a component, pegging shows you exactly which parent item, maybe a subassembly or even a specific finished product order, is creating the demand for that component. It's super useful for understanding the impact of shortages. If this part is late, which final products are affected, pegging tells you that.
So it links the lowest level part back up to the customer order or final product.
Interesting. And it sounds like the system allows for constant reaction, but maybe it shouldn't always be used that way. That's a subtle but important point the source makes. Just because the system can calculate the impact of every little change and suggest adjustments doesn't mean a manager should react every single time. It encourages thoughtful decision-making, not just knee-jerk reactions to system messages.
Right. Use the information wisely.
Exactly. And just briefly, while MRP is primarily a planning and scheduling tool, often with fixed lead times assumed in its calculations, it can integrate with just-in-time or JIT philosophies. JIT is more about execution, moving material quickly, and minimizing waste. That integration often involves things like planning in smaller time buckets, maybe using backflushing, where component usage is recorded automatically when a finished good is completed, and generally aiming for a smooth, balanced flow.
And the source also lists several lot sizing techniques like lot for lot, EOQ, part period balancing, the Wagner-Whiten algorithm that suggests some real math underneath it all.
Oh, absolutely. Lot sizing is about deciding how many of a component to order or make at one time. Do you order just what you need right now, lot for lot,
Right.
or a larger, more economic quantity, EOQ? These different techniques try to balance the costs of placing orders or setting up machines against the costs of holding inventory. There's some sophisticated optimization involved in picking the right lot sizing rule for different situations.
This is where things get really interesting for me. MRP wasn't just a one-hit wonder. It evolved quite dramatically, didn't it? Tell us about those extensions.
It really did evolve. The first big step was creating Closed Loop MRP. The key difference here was adding feedback loops. Original MRP kind of just exploded the requirements. It told you what you needed. Closed Loop MRP added capacity planning into the loop. It checked if the plan was even feasible given your resources. And it also integrated feedback from the shop floor production activity control. So it knew what was actually happening, not just what was planned.
Okay, so it's not just here's what you theoretically need, but here's what you need, and do you actually have the capacity, the machines, the people to make it?
Exactly. It closes the loop between planning and execution. And within that capacity planning piece, there are tactics to try and smooth the load if the initial plan shows overloads. Things like overlapping, starting the next step before the first is fully done, operation splitting, running a job on two machines at once, or lot splitting, breaking a big order into smaller ones to maybe run some earlier, all aimed at managing capacity better.
And from closed loop MRP, we then move to MRP II, right?
Yes, MRP II, which stands for Manufacturing Resource Planning. This was a much bigger leap. It took closed-loop MRP and started integrating other major business functions. We're talking finance, marketing, engineering, human resources. It aimed to be a single coherent plan for the entire manufacturing business, translating operational plans into financial terms and vice versa.
A real company-wide system then, not
Right.
just for the factory floor.
Correct. And the final evolution, as shown in our source, is Enterprise Resource Planning, or ERP. ERP is really the culmination. It takes the MRP2 concept of integration and extends it even further. It adds strong links to customers' CRM functionalities and to suppliers' supply chain management functionalities. The source nicely maps this out. MRP starts things off, closed loop adds feedback, MRP2 brings in best practices in sales and operations planning, and then ERP provides this common database, total cross-functional integration across the entire enterprise and often beyond into the supply chain.
That's incredible. It's gone from just calculating parts needs to potentially managing almost every aspect of a business and its external relationships. And I saw there's even an extension for the distribution side of things.
Absolutely. That's distribution resource planning, or DRP. It basically applies the same logic as MRP, but to the distribution network warehouses, distribution centers. Instead of calculating component needs based on a production schedule, it calculates finished goods inventory needs at different points in the supply chain based on forecasts or customer orders. It needs similar inputs: demand forecasts, gross requirements, desired safety stock levels, accurate transportation lead times, and a clear map of the distribution structure. It's MRP for getting the product out to the customer efficiently.
It's easy to think these systems are just for, factories making tangible things. But the source points out something surprising. MRP concepts can actually be applied in services too. How on earth does that work?
Yeah, that is a really interesting twist, isn't it? The principle applies when the demand for one service element or items needed for a service is directly dependent on the demand for another parent service.
Can you give an example? It's a bit hard to picture.
Sure. Think about a restaurant again. The demand for, say, bread rolls or specific sauces isn't independently forecasted. It depends directly on how many main courses are ordered, right? Or consider a hospital. The demand for specific surgical kits, sterile supplies, even specialized nursing skills for the OR, that demand is dependent on the number and type of surgery scheduled. The source even shows a kind of bill of material, but also a bill of labor for making veal picante. It breaks down the ingredients, materials, and the required cooking steps, labor, just like you'd break down a manufactured product. It really makes you wonder, doesn't it? What other services, things that seem intangible, could actually benefit from this kind of structured requirements planning approach?
Wow, what a journey. We really went deep there. We started with just classifying inventory and ended up looking at these incredibly sophisticated integrated ERP systems that manage, well, pretty much everything from tiny components to global supply chains. You've definitely got a shortcut now to understanding the real power behind materials requirement planning and how it grew into what it is today.
Yeah, and hopefully you've had a few aha moments there. Seeing how managing complexity often comes down to getting the fundamentals right, like that dependent demand concept or the absolute need for accurate beta, that 99% inventory accuracy figure. These systems rely on discipline, but the payoff in efficiency and customer satisfaction can be massive. It's about orchestrating all those moving parts.
So what does this all mean for you listening in? Well, next time you pick up almost any product, or maybe even when you're ordering food at a restaurant, just take a second. Consider that invisible, complex web of planning and coordination that had to happen, making sure all the right bits, the right ingredients, the right tools were all there, exactly when needed. Often thanks to the legacy of MRP and the systems it inspired. Makes you wonder, doesn't it? What other hidden systems are quietly orchestrating the conveniences and complexities of our daily lives?